Imagine an object moving in uniform circular motion with a constant speed v. During some time interval, the object moves from point A to point B along the circular path. The distance that it travels during this time is the arc length of the circle between point A and point B. This arc length is represented as delta L and is equal to the product of the radius of the circle and the angle between points A and B. Here, the angle is expressed in terms of radians and not degrees. Recall that average velocity is defined as the displacement divided by time. When the angle is small, the displacement approaches the distance traveled, which is equal to the arc length between point A and point B. So the average velocity is equal to the radius multiplied by the angle and divided by the time. But since the radius is constant for the circle, then velocity is defined in terms of the change in angle over time. So the component of velocity that is changing is the angle, or the direction of the velocity vector. This rate of change of the angle is called the angular speed and is given by the symbol omega. Since the angle is measured in radians and time is measured in seconds, then the unit for angular speed is radians per second. So the linear velocity can be written as the product of the radius and the angular speed. V is equal to r times omega. Let's have a look at an example. Consider that the Earth rotates about its axis approximately once every 24 hours. The Earth can be approximated as a spherical ball. Let's determine the angular speed of a person standing on the equator where the radius of the circular motion is approximately 6,371 kilometers. So we start with the definition of angular speed, being the rate of change of the angle with respect to time. So the Earth rotates one full revolution every 24 hours. One revolution is one cycle of a circular orbit. How many radians is there in one cycle? One revolution is 360 degrees, which is equivalent to 2 pi radians or 6.28 radians. As for time, we need to know the time in the SI units of seconds. We know that it takes 24 hours to complete one revolution, and there is 60 minutes in each hour and 60 seconds in each minute. So we multiply 24 hours by 60 minutes per hour by 60 seconds per minute. We can see in the denominator that the units of hours cancel out and the units of minutes cancel out, leaving us with the required unit of seconds. So there is 86,400 seconds in 24 hours. Thus, the angular speed of the Earth rotating is 2 pi radians divided by 86,400 seconds, or 7.3 by 10 to the negative 5 radians per second. This is a very small angular speed. If it wasn't, then we might all get very dizzy. So what then is the linear speed of the person standing on the equator? Now that we know the angular speed and the radius of the Earth, we can calculate the linear speed using the formula where the velocity is equal to the product of the radius and the angular speed. This works out to be 465 meters per second, or around 1,670 kilometers per hour. This speed is extraordinarily fast. But the fact that everything else on the surface of the Earth is moving at the same speed, we don't notice it because relative to everything else, we're not moving at all. In summary, angular speed is defined as the rate at which the object changes its angle in a given time period. The angle is measured in radians, and the unit for the angular speed is radians per second. The angular speed of an object moving in uniform circular motion is related to its linear speed through the formula angular speed being equal to velocity divided by the radius.